All right, well, let's get started. Today we're going to talk about terrorist nukes. Now, later in this course, we're going to talk about nuclear energy, we're going to talk about radiation, we're going to talk about nuclear weapons. But in today's lecture, I just want to talk a little bit about, in keeping with the 9/11 theme, talk about terrorist attacks and some of the physics that is associated with such an attack. And today we're going to concentrate on nuclear weapons, potentially in the hands of terrorists. So the first question is, well, how much damage can a nuclear weapon do? I mean, we know from popular media that we have enough nuclear weapons between us and Russia to incinerate the entire Earth many, many, many times. But what's the impact of a single nuclear weapon? So suppose we were to drop a nuke or explode a nuclear device in Kansas, where I am. Well, to quote Blofeld in the 007 series Diamonds Are Forever, if we destroy Kansas, the world may not hear about it for years. So let's choose a different target for demonstration purposes. How about if a nuclear device hit San Francisco? What we're seeing here is downtown, the center of downtown San Francisco. You can see you're out on a peninsula here. And what we see is the effects of a 1 kiloton device. 1 kiloton, remember, we're always talking about tons of TNT equivalent. All right? So a 1 kiloton device, and so what do these colors mean? Well, the red circle means everything is destroyed by fire. The blue circle, which in this case is a little larger, means all buildings are wiped out by the blast itself, just the pressure waves from the blast. And then the yellow circle around that means that there is, quote-unquote, significant damage due to flying debris. Okay? We don't talk about radiation yet because, well, in this course we haven't really discussed radiation and how damaging or not damaging it can be. So we'll neglect for the moment talking about radiation. A 1 kiloton device, by the way, that's a very small device. As a matter of fact, it's roughly the size of the failed, what's considered to be a failed nuclear test by North Korea in 2006. So this is a pretty puny device, and yet it does a fair amount of damage here. Okay, well, a larger device, maybe 20 kilotons, equivalent of TNT. Once again, the blue is the buildings knocked down by shock waves. Now the red is a little larger than the blue in this case, and that's everything is burned inside the red circle, and then the yellow is flying debris. A 20 kiloton device is approximately the impact of one of the weapons that were dropped on Japan in World War II. So this would be the equivalent of a Nagasaki bomb or a Hiroshima bomb. And much bigger impact, of course, lots more damage, lots more death. All right, this is a 1 megaton device. And in this 1 megaton device, everything in this blue circle, once again, has been knocked down. All the buildings have been knocked down just by the blast. And now the red is just this whole area. You can see just the edge of it, and that's all flame. Okay, the ocean doesn't burn, but everything catches fire that can catch fire. All right? And then the yellow thing is way out here. By the way, these calculations were done by a program that anybody can download from a website of the Federation of American Scientists. And so they maintain this package, and anybody can run this online. So just Google it and you can find it. So a 1 megaton device, that's sort of the size of a small H-bomb. And we'll talk about the difference between an H-bomb and these other bombs, which are fission bombs. Okay, so this is a hydrogen bomb, a small hydrogen bomb. It's about the size of the bomb that's being carried by our B-52s. Okay, so the big question for today is could a terrorist group build a bomb like the ones whose impacts are shown in those pictures? Well, not likely. It's really tough to do for a terrorist group. But could they build something maybe less compact than a bomb that our military can build in the U.S., and maybe not as powerful as, say, our military can build? Well, yeah, but it's really hard. The big difficulty is getting a hold of the bomb material. The fissionable fuel, if you will, is tough to get a hold of, and we'll talk a little bit more about that. Okay, so first of all, what kind of nuclear devices are there? We have to get our terms straight so we can talk intelligently about this. First, you have fission bombs. The first two devices that I was pointing to are both fission bombs. The third one, the really big explosion, that's an H-bomb. So a fission bomb is also known as an atomic bomb. It's also known as an A-bomb. Okay, its power range is about the equivalent of 1 ton of TNT, which seems like a lot, but for nukes it's pretty small, up to about 500,000 tons of TNT. You can get all of that impact depending on how much fuel and the arrangement of fuel, etc., for a fission bomb. The fuel in a fission bomb is either uranium-235 or plutonium-239. We'll talk a little bit more about what these numbers mean later on in the course, but basically what it means is that uranium, there are several species of uranium, several species of plutonium. Most atoms have several kinds of species associated with them, and not all will work for nuclear devices. For a fission device, you really have to have this 235. The most common species in nature is 238, but 238 can't make a bomb out of it. Need 235. And for plutonium, you need to have 239. Plutonium doesn't exist in nature at all, but what you get out of a power reactor, you get a lot of plutonium. It's just produced in the power reactor, but that's mostly, it's got some 239 in there, but it's got a lot of 240 as well, and that has profound implications. We'll talk about that in a minute. So you need to have uranium-235 or plutonium-239 now to make a fission bomb. Now a fusion bomb is also known as a thermonuclear device, and it's also known as an H-bomb or hydrogen bomb. The power range is pretty big. It's over 50 megatons of TNT is possible, although most are smaller than this. As I said before, it's about 1 gigaton of TNT per bomb carried by a B-52 bomber. The fuel is actually triggered by a fission bomb. So to make a fusion bomb, you first have to make a fission bomb. The fission bomb compresses the fuel and gives you enough heat to trigger the H-bomb. So an H-bomb is really hard to make because you first have to make a fission bomb. So probably no terrorist group would ever try to make a fusion bomb because it's much, much harder to do, and they're already going to get a lot of wallop out of a fission bomb if they could make one. Now, a third kind of bomb we haven't talked about yet is a dirty bomb. A dirty bomb is also known as a radiological device. It's not in the same category, these first two. The only thing that makes it at all similar is all three of these types have radioactive material involved. What a dirty bomb is actually, it's a conventional bomb, a non-nuclear bomb, and its fuel is conventional explosives, TNT, nitrates, gunpowder, etc., firecrackers, what have you. So it's a conventional bomb, but you add in nasty stuff, nasty radioactive materials. And so the whole point of the explosion is to disperse the radioactive materials. Okay, so whereas in these cases, the first two cases, you get radiation, the main wallop from these first two is the explosion itself. In this case here, you have an explosion, but the main purpose of this bomb is to disperse radioactive materials using this conventional explosive.